Hey, mathematicians, 12-3, surface area of pyramids and cones. Let's do it. All right, so a regular pyramid, again, there's that word regular. That means that its base is a regular polygon. All the sides of the base are the same. The slant height is the height of the lateral face. All right, so that's different than the actual height of the figure. So just keeping that in mind. Okay, so now we're going to talk about lateral area and total surface area. So lateral area, just like we talked about in 12-2, is the area around the sides. It's like the label on the soup can, right? The surface area is the whole thing. It includes the base, all right? So when you're finding the lateral surface area, it's 1/2 the perimeter times the slant height, all right? When you look at this picture, here's my slant height. It's that lateral side height. It's the perimeter times the slant height divided by 2, which kind of makes sense because they're all triangles, right? Area of a triangle is base times height divided by 2. It's kind of what we're doing here. To get the surface area of the regular pyramid, we're going to take that 1/2 perimeter times the slant height and add the base to it. Add the area of the base. All right, so that's going to be the total surface area. So the lateral area and surface area. So the lateral area is equal to 1/2 the perimeter times the slant height. And then the surface area is equal to 1/2 the perimeter times the slant height plus the base. Okay. Now these formulas again will be on your assessment. I cannot interpret for you what they mean on that day. You need to know that piece of it. All right. So here we go. 1/2 times the perimeter. It looks like the base is a square, so that's 32 times the slant height. They don't give me the slant height. I need to figure it out. So what I have here is a right triangle, and I need to figure out what that slant height is. And so I'm going to say 4 squared plus 6 squared is equal to c squared. So 16 plus 36 is equal to c squared. 52 equals c squared. And so the square root of 52 is 7.21. So 7.21. Okay, so using Pythagorean's theorem to help that out. So we're going to get a lateral surface area of approximately 115.36 meters squared, because we're talking area. And now the total surface area is going to be that 115.36 plus the area of the base, which is 64. It's a square, so 8 times 8 is 64. So I'm going to add 64 to this, and I'm going to get 179.36 meters squared. Total surface area and my lateral surface area. All right, find the area of the regular pyramid, round to the nearest hundredth. Okay, so again, it's going to be 1/2 the perimeter times the slant height. That's going to be my lateral surface area. And then my total surface area is 1/2 the perimeter times the lateral or the slant height plus the area of the base. So it looks like I've got a 1, 2, 3, 4, 5 hexagon. So if each side length is 10.4, we're going to multiply that by 6. So my perimeter is 62.4. The slant height is 15. So we're going to take that and multiply it out. So times 15 divided by 2. So we have a lateral surface area of 468 centimeters squared. Then to find the area of the base. Now we've got to pull back the skills that we were learning in chapter 11 about finding that. So I'm going to sketch out my hexagon. Doesn't look real regular, but I'm getting the feel. This is 10.4, and I need to find the apothem, because to find the area of that triangle, I got to find, or that base, I need to find the apothem. So if I've got 6, this is a 30. So when I look at my triangle, this angle measurement is 30. This is 5.2, so I need to figure out x. Well, in a 30, 60, 90 triangle, I know the relationship from the side opposite 30 to the side opposite 60 is multiplying it by the square root of 3. So the apothem is going to be 5.2 square roots of 3. Okay? So I've got 468 plus the area of the base is 1/2 the perimeter times the apothem. 5.2 square roots of 3. All right? So I'm going to take that, multiply that out, 62.4 times 5.2 times the square root of 3. And then I'm going to divide that in half. And that's going to give me 281.0. So 468 plus 281 would be 749 centimeters squared. So still using that idea of the apothem and trig functions, which is super exciting, right? Okay, here we go. The axis of the cone is the altitude if it's a right cone. The axis is not the altitude if it's oblique. And oblique means it leans. All right, so a right cone is like straight up and down, right? The oblique, it leans. All right, so to find the lateral and surface area of a cone, again, we will have these formulas for you. You need to know how to interpret them, right? You need to know what every letter means and so on. So the lateral area is pi r times the lateral, the slant height, and that's right here. And then the surface area is the area of the lateral area plus the area of the base. So let's take a look here. So surface area, so we're going to use this formula right there. So pi times the radius times the slant height plus pi times the radius squared. So here we go. We've got pi times 1.4 times 3.2 plus pi times 1.4 squared. That gives us a total of 20.23 centimeters squared. Fantastic, right? Total surface area. All right. Conical birthday hat has an altitude of 6 inches and a diameter of 4. Find the birthday hat. All right, so we're going to take pi times radius times the slant height. So as an altitude of 6, it has a diameter of 4. And I need to know the slant height in order to find the lateral area. So then this piece is going to be 2. Right, here's 2. All right. So what I'll do then is I'm going to take 2 squared plus 6 squared is equal to c squared, using some Pythagorean's theorem again. 4 plus 36 is c squared. 40 is c squared. So c is equal to 6.3. Right? And c is my lateral, my slant height, I mean. So pi times my radius, which is 2, times my slant height, which is 6.3. So multiply it by pi, multiply it by 2. I'm going to get 39.73 inches squared. And there you go. All right, so this is just a refresher for you, all the different formulas. Again, we're going to give you the formulas. We're going to give you this on any assessment. You need to know how to use those, though. Have a fantastic day. Take care.